Today's topic, efficiency of a transformer. Previous class we studied about efficiency of a transformer. That is, efficiency is given by output power by input power. So that efficiency is totally is given by the relation what I have shown on the screen. Now, condition for maximum efficiency. What is a condition for maximum efficiency? The load current at which the efficiency attains maximum value is denoted as I2, and maximum efficiency is denoted as efficiency max. The efficiency is a function of load, that is load current I2 assuming cos phi2 constant. The secondary terminal voltage V2 is also assumed constant. So for maximum efficiency is, actually it should be differentiated with respect to the variable and it should be equated to 0. When we do that, we land up with this relation we are doing here. We finally landed up with this condition to achieve maximum efficiency is that iron loss is equal to copper loss. So what is the load corresponding to maximum efficiency? For constant V2, the kVA supplied is function of load current. kVA at maximum efficiency is the relation what is given here. Substituting the condition for efficiency maximum in the expression of efficiency, we can write the expression for efficiency maximum as shown in the diagram. So here we have understood about the maximum efficiency, load at which maximum efficiency occurs. That is, at which load you get iron loss is equal to copper loss, because at every load it will not operate. I mean, at every load, at each load, you don't get the maximum efficiency. At one particular load, iron loss becomes equal to copper loss. At that particular load, what will happen? The efficiency you will get maximum. The same way, you can get the efficiency for all the loads, but maximum efficiency can be achieved only by using that, applying that iron loss is equal to copper loss, that condition. When that condition is achieved, only then you can say that it is equal. Then similarly, we can say about voltage regulation of a transformer. What is voltage regulation of a transformer? See, you know that what is regulation? Because of the voltage drop across the primary and secondary impedances, it is observed that the secondary terminal voltage, you can look at the screen. If I go back, I can show you the circuit. You look at the circuit where you can have this one. Say for example, this is because of the voltage drop across the primary and secondary impedances, it is observed that the secondary terminal voltage drops from its no load value to load value, full load, as load and load current increases. This decrease in the secondary terminal voltage expressed as a fraction of the no load secondary terminal voltage, which is called as regulation of the transformer. The regulation is defined as the change in the magnitude of the secondary terminal voltage when full load, that is rated load of specified power factor supplied at rated voltage, is reduced to no load with primary voltage maintained constant, expressed as the percentage of the rated terminal voltage. Now, percentage, if you want to write mathematically, the voltage regulation at given load can be expressed as percentage voltage regulation is equal to E2 minus V2 by V2 into 100, where E2 is nothing but the secondary terminal voltage. I can show you here. E2 is nothing but secondary terminal voltage, and V2 is the secondary, E2 is secondary terminal voltage on no load. V2 is secondary terminal voltage on given load, and it is expressed like this. The ratio E2 minus V2 by V2 is called per unit regulation. The secondary terminal voltage does not depend only on the magnitude of the load current, but also on the nature of the power factor of the load. If V2 is determined for full load and specified power factor condition, the regulation is called full load regulation. The regulation depends on the power factor of the load. In case of lagging power factor, V2 will be less than E2 and we get positive voltage regulation. While for leading power factor, E2 is less than V2 and we get negative voltage regulation. This is the voltage drop should be as small as possible. Hence, less the regulation, better is the performance of the transformer. Okay. So, for calculating the regulation of a transformer, the voltage regulation is defined as percentage regulation is equal to total voltage drop by V2. Total voltage drop is nothing but E2 minus V2 by V2. The regulation together can be expressed like this: total voltage drop by V2 into 100, where I2 is secondary current on no load, V2 is secondary voltage on no load, R2 and X will be the equivalent resistance reactance when you substitute E2 as I2 R2 cos phi and V2 as I2 X2 sin phi, like that. Equivalent X2 is equivalent reactance referred to secondary, where cos phi is load power factor. What is that plus sign? Plus sign will always indicate for lagging power factors, while minus is for leading power factors, loads. So this is about the percentage voltage regulation in a transformer.